Hopefully you can see it now.
Much better.
By the way, if you go to the same address without the extension of the file name, you're going to see some information about the course that I'm developing, that this is a teaser, a trailer for. And if you're missing the address or having any issues, you know my email address. And you can
Is it in there?
Are you going to, are the students going to be using those data files on SPSS on these machines?
I hope we can get to that point.
Okay. So then we'll take it. Yeah.
I hope around 11:30 to get to that point where we can start loading. Before the SPSS, there is some work to be done. So.
Does it matter if it's an older version of SPSS? Or
No, it doesn't matter. All the SPSS is exactly the same thing in terms of the analysis that we're looking at here as well. Now they all. So if you're interested in the course information, this is the course.
Is the RESD case sensitive?
Yes, should be. Yeah.
Make sure you got 2 lives on levy too.
Oh, yeah. Thank you.
Can I throw these either on here or on here? Are you going to run SPSS on here?
There's probably more
Or
coming
you
out.
use SPSS?
I
I
was
was
trying to get the files.
Endnote class are just wrapping up.
Okay. And then there's a folder here called Movie. But
So you guys that are on the PCs, you're not going to use the Macs?
No, I asked them to pull up their computer to download some of the files to their local.
Oh, yeah. Because I was going to say, if people don't have Macs, then they could be at the table.
Right.
Just because it gives
Right,
room
we
for
have,
anyone coming
right
in.
now we have enough, and I need to get going shortly because.
clear, so I'll know I can pull that.
So let's wait a few more minutes and then we can get started. Good morning.
Hey, Simon. I
Well, if you,
saw your
yeah,
note.
because
I'll
this
get
has
it to you.
SPSS installed on it.
Good morning.
This machine does. So if you're going to
I'm doing
actually
good.
running SPSS, you can do that up here. But then if you want to make notes about the
Sorry,
PowerPoint,
come in.
if you want to do
Yeah.
that on the machine,
Did yours take a while to come in?
No, actually, you clicked on Levy? That folder?
Which folder?
Right on your right.
It hasn't come up? Oh.
Okay.
Yeah, click on
Sorry.
that one. That's
I
the-
missed that instruction.
Take it out real quick.
Okay, so you just run this?
Yeah, I just put it on
I
PowerPoint 1.
think it'll be okay.
Watch your toes.
PC.
We just fixed one thing at the top there.
Oh, okay.
Let me zoom out for a second.
Oh, you'll be able to have the
You're
files from
such a
that, from that
pretty
URL.
boy.
Send
Oh,
it,
right,
you
it's the
can
same
load it down
stuff.
to your
Same
PC
stuff,
if
so
you
you'll be
have
able to
one.
get it.
If not,
I should be able to mail it to myself though, right?
the internet's not working, so.
Oh.
The guest should work. If you plug into the guest account.
No, it's full.
Should you have the Apple
This is
account?
my,
Yeah, your
You
hotspot,
can
right?
use your app. Well,
Where did you get that one?
this is just one that I use for disaster recovery in my office.
Confirmation.
It is a disaster recovery right now. I'm telling you.
I don't want to say.
First one where I've actually seen them over there.
I mean,
And
Verizon,
the plan is to
Verizon,
start
it's,
where they are.
you know, it's a-
Which is where they'll do
what do you call it,
contact us first. And then
got
what we could
communication
do is
card.
we could say, look, for doctoral
Oh, okay.
courses, we want to have a 2-year history, something like that.
Just plug it into the USB.
thank you.
Sure.
I think you're
You want me to-
Okay, guys,
Yeah.
I think we should get going. All of you guys took down the address both for the course and the workshop that we're going to do today. That's essentially what I shared with you. I just want to tell you quickly, and you should, Dr. Siegel distributed the files also on these machines. There are 4 PowerPoint slides sets that I created. I'm very ambitious. The content here is for about 6 hours. Okay, so we'll try to do it in an hour and a half. I'll have to talk fast, and if you want to get more of this, this is what will happen in the upcoming course. I know most of you, not all of you, are done with coursework, but that's something you need to look into. Either go through this, or we're going to record also my course, so eventually I'll put it online somehow. We might think about creating a MOOC or something, or I don't know. We'll see how that will be developed as we go. Hopefully it will be okay. The first 4 files are the slides. Then there is a cheat sheet for Mahalanobis distance, which is outliers. I will touch it a little bit today. I want to actually have you guys run it. I also hope we can get to Cronbach alpha, and I'll teach you how to calculate Cronbach alphas on constructs. If we can do that quickly, that would be nice. And then I'll teach you briefly if we can do factor analysis, a little bit of principal component analysis, which is exploratory. We'll see if we can do that. I give you 2 data sets in here. Caveat on those 2 data sets. These data sets are, thank you, I appreciate it. These 2 data sets are available for you to use for the purpose of the workshop. Please don't go and publish any research from this, okay? I'm asking you not to do that. Some of the data is co-owned by me and my students, former students, so please. The first one was actually published already. This is data from the Navy that we published way back. It's actually partial data from that. And then I'll show you some of the issues that we encounter in the preparatory stages of the data phase. And so part of the issues that we have with multivariate data is to understand the holistic view of how to capture the data, what do we need to do to prepare the data, what are the preliminary things that we need to do before we dive into hitting the run on the SPSS. And these are the big issues that I want you to take away from this session today. So with that, I want to start with a little bit of intro for my my first presentation, and then I'll show you a brief video that will outline a little bit about what we're talking about in terms of multivariate research in general. We'll talk about some of the assumptions and limitations. This is the biggest area that most dissertation students skip, completely skip. The area of assumptions and limitations of the multivariate data, trying to understand your data more before you run into plug it into SPSS and just hit the run on a couple of analyses and try to understand what you got there. And that is very crucial. If you don't understand that, you get results from SPSS and you have no clue at the confidence level of what you're getting, because some of the issues that you will get from the analysis might be marginal. And if you have looked thoroughly into the assumption violations, you might have cleaned some of those issues and you were able to address that better. With that, I want to tell you, so we'll do that. This will be the first presentation, and then we're going to move into some cleaning and preparatory of the data, and then some collections. How do we collect multivariate data? I'll show you using the simple free Google Forms approach. And the assumption is basically to use surveys, and we'll talk about some other ways of collecting data. With that, and then after that, I'll have another session that will talk about some analysis itself. Couple of things. Majority of the material that I'm going to go over is coming from this book. You have the source in the slides. You also have it if you go to the website for the course that I posted before, the RESD 720. If you go there, this book and the other book are listed. I'll talk about the other book in a minute. But essentially, this is a fundamental multivariate book that you really need to get it. Those of you who have been working with me, and once you move from a pre-idea paper to a full idea paper, I require you to actually get the copy of this book. This is a brand new 2014 edition. Came out this month actually as the 2014 copyright, and it's very good. There are a couple of issues that we'll discuss. Some of them we will skip. It depends on the type of methodology. So that is one of them. We'll talk about the second book later. And so with that, keep this in mind and you have it in your sources. One thing that you gotta think about research is always, right, the philosophy is that, right, if the facts don't fit the theory, change the facts, right? Hopefully you will go and change your theory, not the facts, because of what you're gonna observe. So we'll talk about that in a moment. What we'll do now, I want to do an introductory. I will run a short video for you that will give you a little bit of an overview of what do we mean by multivariate, okay? Then I'll go in and I'll actually define it in a more advanced way so we are all on the same page. I'll talk about the assumptions and limitations as I mentioned here. And what you see here is essentially a graph representing before and after tests of measures on 12 different variables that we did in one study. And with that, I want to run a short video that I'm really excited about this. This is more on data analytics and visualizations of data, but it actually emphasized some of the ideas of multivariate in terms of making sure that we use beyond the 2 variables or the 3 variables, but we also go into the deeper understanding of what happened to the data when it goes over time, or how is it changing. And this is what multivariate is about. So with that, let me switch for a minute to this video. And let's watch this. We're going to watch only the first 5 minutes. So hopefully, I hope you can hear it. It's just coming out of the machines.
About 10 years ago, I took on the task to teach global development to Swedish undergraduate students. That was after having spent about 20 years together with African institutions studying Hungary and Africa. So I was sort of expected to know a little about the world. And I started in our medical university, Karolinska Institute, an undergraduate course called Global Health. But when you get that opportunity, you get a little nervous. I thought, these students coming to us actually have the highest grade you can get in Swedish college system. So I thought maybe they know everything I'm going to teach them about. So I did a pre-test when they came. And one of the questions from which I learned a lot was this one. Which country has the highest child mortality of these 5 pairs? And I put them together so that in each pair of country, one has twice the child mortality of the other. And this means that it's much bigger the difference than the uncertainty of the data. I won't put you at a test here, but it's Turkey, which is highest there, Poland, Russia, Pakistan, and South Africa. And these were the results of the Swedish students. I did it so I got a confidence interval, which was pretty narrow, and I got happy, of course. I 1.8 right answer out of 5 possible. That means that there was a place for a professor of international health and for my course. But one late night, when I was compiling the report, I really realized my discovery. I have shown that Swedish top students know statistically significantly less about the world than the chimpanzees. Because the chimpanzee would score half right. If I gave them 2 bananas with Sri Lanka and Turkey, they would be right half of the cases. But the students are not there. The problem for me was not ignorance, it was preconceived ideas. I did also an unethical study of the professors of the Karolinska Institute that hands out the Nobel Prize in medicine, and they are on par with the chimpanzee there. So this is where I realized that there was really a need to communicate, because the data of what's happening in the world, and the child health of every country is very well aware. So we did this software which displays it like this. Every bubble here is a country. This country over here is this is China. This is India. The size of the bubble is the population, and on this axis here, I put fertility rate. Because my students, what they said when they looked upon the world, and I asked them, what do you really think about the world? Huh? Well, I first discovered that the textbook was Tintin mainly. And they said the world is still we and them. And we is Western world, and them is third world. And what do you mean with Western world? I said, well, that's long life and small family. And third world is short life and large family. So this is what I could display here. I put fertility rate here, number of children per woman, 1, 2, 3, 4, up to about 8 children per woman. We have very good data since 1962, 1960 about, on the size of families in all countries. The arrow margin is narrow. Here I put life expectancy at birth from 30 years in some countries up to about 70 years. And 1962, there was really a group of countries here that was industrialized countries, and they had small families and long lives. And these were the developing countries. They had large families and they had relatively short lives. Now what has happened since 1962? We want to see the change. Are the students right? It's still two types of countries? Or have these developing countries got smaller families and they live here? Or have they got longer lives and live up there? Let's see, we stop the world, and this is all UN statistic that has been available. Here we go, can you see that? It's China, they're moving against better health, they're improving there. All the green Latin American countries, they are moving towards smaller families. The yellow ones here are the Arabic countries, and they get larger families, but they, longer life, but not larger families. The Africans are the green down here, they still remain here. This is India, Indonesia is moving on pretty fast. And in the 80s here, you have Bangladesh still among the African countries there, but now Bangladesh, it's a miracle that happens in the 80s. The Imam start to promote family planning, and they move up into that corner, and in 90s, we have the terrible HIV epidemic that takes down the life expectancy of the African countries, and all the rest of the world moves up into the corner where we have long lives and small family, and we have a completely new world.
So what are we learning from this? We're learning that essentially multivariate or collecting data is beyond few simple variables. The idea is that sometimes if you take the data and you grab additional variable, like in this case, it's the time, the year, the progression of time, that can tell us a big story. Right? That's the key here. The key here is that you need to understand the phenomena that you're trying to investigate, and therefore try to find the right variables to add to your set of variables that will allow you to create not these fancy animations, right? Necessarily, but create an analysis that will give us additional information about the phenomena that we're studying. So with that, let's talk quickly about what do we mean by multivariate. And so there is growing research, and most likely every research that you guys read is a multivariate. It has more than 2 variables in it. It's trying to analyze an approach where you have multiple variables that are interchanging, interconnected, that are impacting the given phenomenon. So the idea is to try and look into those multiple independent variables, right? And I'm going to start using some acronyms throughout, so you guys, probably most of you are aware of those, right? The IVs. We're looking at multiple dependent variables, which is kind of, some people, for them, this is unique. But this is type of an approach that multivariate can handle, including some interesting path analysis and impact type of model testing that can actually help us produce models with more than one dependent variable, unlike the traditional linear regression and things like that. You must have only one dependent variable. We'll talk about that as well later on. And of course, the ability to control for different things. So if we would like to run the same data that Heinz was running over there, but control this based on, let's say, some economical factor of the country, normalize the data based on that, this is what we call a control variable. So we'll hold that variable constant and see how all the rest of the variables change while we are holding that variable constant. And I'll explain this a little bit more when we get to some of the covariate type methodologies. And again, what we're going to do today is really a tease to something that is very large. This content by itself is a 16-week long course. And so I'm going to just provide you a little bit of an overview, if you will. And then hopefully we have a little bit of time to play with some data. So what is the difference between univariate and multivariate? Simply putting it into visual, the idea is that if we look into a single measure on a single variable, leading to or checking how that impacts a single measure on a single variable, that might be a univariate type of analysis here. So you might see correlations and simple things like that, which have major assumptions and limitations that most people don't aware of it. We'll talk about that in a moment, but that might be a simple univariate. And then multivariate will be something that we might look at the impact of multiple variables together at the same time on a couple of other variables. We might have either mediating or other types of moderating variables, and I'll mention this in a moment. But the idea is that we're starting to develop more of a models that we test in order to look at the impact, or, and this is one example, or we're looking at more experimental type of research or quasi-experimental type of research where you might have a factorial design or areas like that. I'll mention this as well, where you measure things before a treatment, you have a treatment, you measure it after, and there are major variations of that measuring before and after in different control groups, etc. We have a paper that talks about quasi-experiments and experiments. If you're interested to read about it, you can look through my CV, or I can forward it to you. Come and see me later, and that will help you also understand the other type. But in information systems, which is what I assume most of you guys are in the program of information systems, majority of the work that is done nowadays in the top leading information systems journals will be the model testing type of work. Okay, so we'll throw a model based on some theory. We're going to throw a model based on some theoretical foundations, some experimentations that were done in previous research, and then we're going to try to test that model in a certain context. And I'm sure most of you are in your idea paper stages. You probably have a conceptual map that will mimic something like that or similar or variations of that. This is essentially the type of what the top IS journals are looking for, and it depends and it varies, and that impacts also the type of methodology we have. So with that, again, teasing you with some notations, we have two notations. One is called the mediating, and one is called the moderating. And think about this. It's very simple when you think about it in a divorce process. And I don't want to give it a bad connotation here, but it might help you realize, right? So when you have the moderator, or think about it when you have a debate, right? You have a moderator there, you have the two people who are debating standing next to each other. They are kind of related, and then you have your moderator kind of trying to see if there are any issues that they can tease the two and bridge between the two. And this is essentially what the moderating variable is. It is looking at the relationship between the two variables, okay? Where we're looking at the mediator, and mediator more from like divorce, right? And so you have a mediator where the parties don't want to see each other, right? They have a third party who's going to grab something from one end and then transfer it to the other end. That's the idea here, okay? So the idea is to capture some of the variability. Again, I'm not gonna go into the mathematical and statistical level of all the issues that we're discussing. This is, I assume you already had the 700 or the intro to the research methods. So the idea here is to take some variability that we have on one variable, and then measure how with the mediator together how that impacts. So of course, usually the impact from here to here will be higher when we add another variable before that as to serve this as a mediator instead of as an independent variable, right? That's usually the case when we put it into an analysis. These two are separate type of analysis, sometimes even separate type of tool. For this, you might need to use SPSS. For this, you might need to use PLS or SEM, structural equation modeling, or tools like that. We'll talk about it also later. But that's essentially, some of these, the way you note them are different. The way you represent them here will be different, which implies what type of research methodology, which implies what type of statistical analysis you're going to do, which implies what type of tool you're going to use. Most of you are not aware of it, so you draw them up and you bring it to us, and we look at it, and we say, but how do you do that, right? We had this issue for a while with the statistical analysis that someone published in top journal, right? And there were some things that we could not find a statistical analysis that they claimed they used actually can do that. And we found that it was kind of a fetchy thing. I'm not going to go into this, but there are ways to go around everything. We found it, but this is not, I'll say, the kosher way. Anyway, so just understand that these are issues that you need to look into. Another thing is the notation of control variables. When we look at control variables, so if we want to measure the impact of, let's say, age on IT usage and productivity and the whole path, we want to control for years of experience of computers, right? To see how controlling it by holding it constant will make any difference in here. We can do that, okay? We can hold that, but that might require additional, more advanced analysis. Okay? Usually what we'll try to look into is not the impact, rather more the individual variables. That might be easier in terms of statistical analysis. So this is where you first design your study. You got to understand that some of these drawings, those conceptual maps that you're going to develop, they're good, but every line that you put in there represent a slew of things that might not work or might work, or the way that you're writing your hypotheses or your research questions is completely different if you do it this way or you do it that way. Okay? In this example is the moderating versus the mediator. So with that, I want to touch on another thing. So we have this basic multivariate that I just talked about in the slide before, right? So we have, assuming that we have an age, which is a single measure. I don't think anyone has a multi-measure for age, unless you can think about ways of measuring age in different ways. IT usage, so let's assume we're measuring it by hours a day, okay? And productivity, let's assume we're measuring it by X, whatever measure of productivity. How many emails you're sending a day, okay? Whatever we assume for that given job, okay? And that might be a basic multivariate when we look at multiple of those. But in information systems, we're dealing with a completely different animal. We're dealing with what we call constructs, okay? Those latent variables. And these are a little bit more advanced than the single measure type of variable. And that is a very difficult thing for most students to get, okay? You need to understand that there are certain things that what we call unobserved variables, okay? Things like satisfaction, competency, or other ways of that we measure. And of course, most of you are aware of technology acceptance models or ease of use, usefulness. All these are latent variables, okay? So if you're looking at satisfaction, for example, from a computer system, this is not a single measure. I mean, yes, you can ask a single question and say, are you satisfied with using this electronic medical records? They might tell you yes, no. Or they might rate it from 1 to 5 or from 1 to 7, which is the more acceptable now in IS journals. Okay? But the idea is that you really want to measure it in a way that you capture all the variable properly from all angles, okay? And this is where we dive into the more advanced areas of what is called formative versus reflective variables. And this is kind of new to even the information systems field. In the past 2 years, 3 years, actually about 8 years ago, someone raised the point that on a review of a paper to Top Eyes Journal, they noticed that half of the measures were reflective and half of the measures were formative, and so some of the results might not be as valid or as credible as it is, and that started a slew of investigation about what are the differences between those two, the formative versus reflective, and it doesn't mean that you cannot have multiple of those types in the same. The idea is, I'll explain it later, but the idea is that some of the variables are actually combination of these items, and some of the variables are just either pieces of the same thing or multiple views of the same thing. I'll elaborate on this when we get to the analysis area, where we will talk a little bit more about what are the differences between formative and reflective. All I wanted you guys to get out of this workshop today is at least you know that there are differences, and when we get there you will understand what are the differences in a moment, okay? And why are we having those differences? It makes a lot of sense when we go to measure multivariate. So talking about those multivariate, one of the biggest issues we have with any analysis, and in particular multivariate, is the fact that most people who are going through their special dissertations are not aware of the assumptions that every analysis will have. The typical case I have is students who come and show me a research paper that was published in a conference proceeding or somewhere, and they use Pearson correlation to check what they call an impact of a variable on another variable. Yet they did not demonstrate that the two variables are normally distributed and that there is a linear relationship there. Pearson is based on linearity. If you violate linearity, it's useless. Okay? So that's one thing. You need to use another type of correlation, which I'm not going to go into this, but there are advanced correlations types for nonlinear. These are very crucial. When you read the literature and you find those things, start grill them, start question. If they use multiple linear regression and the data is all about cognitive value and areas like that, that might not be valid, because we know the majority of the variables that we're measuring that are cognitive, satisfaction, resistance, trust, all these are nonlinear. Okay, mostly nonlinear. So you gotta look into those issues as well. And so when we come in here, there are three major limitations or assumptions that we need to look into before we run any analysis. Okay, and this is critical. The first one is normality. I'll explain it in a minute. It's very straightforward. Most of you know this from any introductory statistic course that you took. So we'll bypass that. Linearity is also making sense. All of you guys remember the linear equations from your high school. So that is very simple. I think the homodicity is probably a little bit more than that, but I'll explain it in the context of linearity, and you're going to see how homodicity is essentially the combination of these two in the multivariate level. So we'll talk about this in a moment. I want you guys to know about those things. So when you go to collect your data, to understand your data, to learn your data, you don't just rush to make analysis and then you try to say, but the data is not working as what I hoped it would. And in most journal articles that you have seen, the data that is published, the results that are published based on the data, that data went through some review, some by the authors, right? Some review, some analysis. You can call it massaging it. You can call it whatever you want. Transformations, I'll talk about that as well. You do things that you need to do sometimes. Of course, the data will tell you or not, but still, those models that you see published in ISAR and MISQ and They show like almost all the paths are significant. The data was not born like that. Okay, let's put it this way. Okay, it's a little bit of work before, and this is what you need to make sure. Because if you throw it into an analysis that violates some of the assumptions, of course you won't get anything coming up. So, normality. Obviously, we all know about the normal bell-shaped normal distribution, the 3 standard deviations plus minus, and the whole idea behind 6 sigma that came from this, right? The idea of expanding this from a 3 sigma to a 6 sigma, so you don't get 99.7%, you get 99.99997%, right, in the manufacturing area. And we have also, we did the study on that area as well, the 6 sigma certifications and stuff like that. But the idea here is this. The idea is that your data is normally distributed before you run analysis that will require the normality assumption. Okay, and so you have data that you might plot it, and if you collect data, you might not get it normally distributed because your data is, let's say, from 1 to 5. So you're going to get only like columns of dots, right? And so the idea is to look into other ways, and I'm not going to dive into this, but there are SPSS tools or techniques that will allow us to actually go into that. I can touch upon one of them. The point is that when we look at the distribution, right, that there is a distribution, that you don't have everything falling on one area as you go through your data. So the idea of normality and that was univariate, right? So you look at it as the bell shape will be for one variable only, right? Now think about it in a 2-dimensional, when we take 2 variables together. And so you might get what we call the elliptical shapes that will tell us that this variable, these 2 variables, the set of 2 variables, each and one of them is normally distributed, but when placed together, they actually form this shape, the elliptical shape, to demonstrate that these are bivariate normality. These are also crucial to some of the multivariate analysis. You had a question?
Yeah, so my question was, one can control that through sample size, the normality. If you've got something which is good, is that not the case?
Absolutely. Not only that, let me tell you other tricks. And there are tricks of the trade to help us with that. So for example, in the past, so absolutely, in terms of sample size, of course, the bigger the sample size you have, the better your distribution and the better you're closer to normal distribution, assuming that your data collection is supposed to be normally distributed. And that I'll touch also in a moment, because your instrument might be biased by nature. Okay, so if you're asking things like satisfaction from something that is by nature a positive experience, it will be skewed anyway. So you gotta be aware of that. Okay, and so we'll talk about transformations, but there are other things. One of the most common mistakes is for people, and we see this in IS as well, is to use the Likert scale from 1 to 5. And so there is a lot of discussion now in the research methods side of information systems that journals will stop publish papers that are based on the 1 to 5, rather move to the 1 to 7. Why? Because then you get better distribution, and then you get better measure for each variable by itself. So in aggregate, you get a better, closer to those. Actually, in a multivariate, when you talk about measures that are Likert type, you don't get the elliptical. What you get is a rectangular, right, in there. And so the idea is to get those rectangulars that are very nicely shaped. But so, and there is some research done on the type of scales, what type of scale to use from 5, from 2, 3, 5, 7, 10, etc. And they actually found out that 7 is really the point where it gives us a lot versus what we get out of it. And of course, you always have the issue of creating, when you create the surveys, to have the issues of the length of the survey, the complexity of the survey, things like that. And of course, what you can see here is a normality on a two variables in a 3D view. So imagine this is only 2 variables, but if you have a survey and you got 40 variables, right? So think about how this looks. Of course, we cannot visualize this in a 40 or 39 dimensions, and that's essentially, but what the tools are doing it for us. They will check those, and they will check bivariate for us, and based on that, we'll go. Another big assumption is linearity. As I mentioned before, there are some research and statistical analysis that are very sensitive to specifically linearity. And the idea is essentially that you create a line, half of the points above, half of the points below. You're trying to minimize the margin of error, the error that you have, the residuals, right? This is the residual, and you try to reduce the residual as much as you can. So you locate the line in a place where it's closest to all of the points at the same time. This is in 2 dimensions. What happens when you have 3 dimension? It's obviously a plane in a 3-dimension space. But what happens if you have 40 points? And this is exactly where you start getting into the principal component analysis. This is what they do. And so what they do is they look at spheres with shapes, and they try to look for centroid across all those points. And I'll talk about it when we get there, and and this is where we try to rotate, and we'll get there also later on today. So that's one of the ideas. Where is this important? Okay, always we talk about statistics, and this methodology and that methodology, but why is this important for us? Well, guess what? If I have a bigger error, if this type of analysis simplified, let's say linear regression, is being used to create a template to identify face recognition, right? If I have my assumption violated, right? If the residuals are bigger than what they should be, than what is acceptable, then I'm starting to get different faces matched, right? And that's exactly what is behind, actually, principal component analysis is the part behind face recognition, okay? And so you need to make sure that you capture multiple aspects and then aggregate them all together to find the best, least errors, right? Least errors that you can do so you can match it the best to that individual. Otherwise, you're hitting the wrong person, right? And that's one example for this assumption violation. So now we're getting into the homoscedasticity, and homoscedasticity is essentially the combination of the 2. If you can think about it as the issue of linearity and normality together, but the idea is that you get not, if they're both in a 2 variables, if they're both perfect, right, normally distributed, you should get the elliptical. But if one of them is skewed, then what you get is essentially a funnel with your data. And that, sometimes it's good, but most times it's a violation for some of the analysis. Again, this is where when you start looking at your own data and your own type of analysis, you need to understand what it means to your results. You might need to go back and maybe do a transformation here and correct it, so when you run the analysis, the statistical significant level that you get is really good representation of what it should be. Okay, and again, I'm not diving into the more advanced areas, I just want to show you those things. So with that, here is another example, and the heteroscedasticity, is essentially looking at this shape, and when it's open, when you have it open, you get this funnel. That will help in some areas. On the other hand, in some analysis, we don't care, right? And that's the beauty of some of the advanced analysis. Structural equation modeling, for example, might not need to obey some of these strict rules, okay? It depends on which one. And of course, there is the parametric and non-parametric. I'm not going to dive into it, but you need to understand that these are important for us. Same thing for the assumption violation. So what does it mean to us when we violate those? As I started mentioning, that it's not the end of the world, right? when I started getting my data on my dissertation, I freaked out. I had 7 variables that were perfectly linear, and then all the rest of like 20 some that were complete disaster. And then my professor said, yes, but did you try to transform it in a log linear? I said, what? So here's the book, go and read. So I read it. I put it in the SPSS log linear, boom. It beautifully sitting on a linear distribution after transformation. Sometimes you need to do that, okay? And so you need to understand what are the issues and how to solve them. And so you might have it skewed, and most data that you guys are going to collect will be skewed, I can guarantee you. Either it's a positive thing, satisfaction, we measured habit, we measured trust, we measured those things, so they might be highly skewed towards one side, or you might have a negative areas like resistance or other things that might be skewed to the other side. And so you gotta understand and look through it. And as I mentioned, I'll talk about robustness in a moment. So what happens if we evaluate those and we just run it in the analysis? Basically, we are either overestimating or underestimating the results. Okay? We have the issue of estimating the significance level, estimating the results. And so these are crucial as well. Robustness, you're going to see this issue all the time popping up in reviews. Okay? Good reviewers to top journals will grill the people on the robustness of their methodology. As a matter of fact, I just got an email this morning from an editor-in-chief telling me that he wants me to review. They are using some structural equation modeling. He's not sure that they're using it correctly, and he's very concerned with the analysis and the data. And of course, sometimes you get papers and there's an editor-in-chief and it's too good to be true. And so you gotta look into it and dive into it. And in this case, the editor-in-chief requested the data. So he's asking me to do some analysis and check the data and verify if the results that the authors claim that they got is really what is there. Now, of course, we need to be aware of those things. In your case, most of your dissertation chairs will ask you for your data and they'll run it on their own. I can guarantee you. If you work with me, I do it all the time. So that's as far as that. I mentioned the issue of transformation, and that's important. Some limitations. Every multivariate analysis has limitations. You gotta understand those limitations. You gotta understand that there might be certain things that you originally hypothesized that maybe a single statistical analysis might not produce for you. You might need to combine, or you might need to look at multiple analysis and compare. And we had a couple of dissertations where we looked at multiple types of analysis and then we compared the results. And that's valid. You know, the papers that you see on the top journals, that's not the first analysis that they were running it. Okay, that's the issue that you need to think about it as well. So with that, I'm going to stop here. Let me switch to any questions so far?
Quick question about robustness. So
Yes.
what kind of tests do you perform to check for robustness?
You need to make sure that the assumptions are not violated.
Okay.
When the assumptions are not violated, that gives you enough confidence that the analysis that you're using is robust enough in order to do what you're trying to do.
Okay.
But it depends on what you're trying to do. If you're trying to demonstrate some path analysis and you're measuring it based on correlation, and even if the assumptions are okay, there are issues there because you need to look at the best methodology to address that type of hypotheses that you're putting out.
Okay. Like satisfaction, for user satisfaction on a system, with one example, satisfaction will be...
Right, but you're talking about one variable. I'm talking about the analysis where we have combination of variables. What do you want to study? The satisfaction in terms of what? How it impacts something else, or how it change over an experience?
Yes, okay.
Okay, so if you check over experience, it's one methodology might be valid for that.
Okay.
And that methodology, maybe ANOVA and maybe other type, these methodologies might need very strict linearity and normality,
Okay.
and the heteroscedasticity. Okay, these are the issues that, so all three for that, for example. But when you move into others, it might not be as sensitive to that. Okay, so the issue here is sensitivity to those assumptions. Okay, so with that, we're done with the assumptions, and hopefully I'm not going to dive into how to actually do some of these. That is probably part of a longer training and session. And so there are a couple of chapters in the book itself that actually talks about that. Chapter 1 and 2 discuss specifically the issues of assumptions. This is how they start because it's so significant for all the analysis. So if you're getting the book, you might want to look. They actually guide you through specifically how to do certain things, normality test, and all the other tests via SPSS. In this case, what I want to dive into is look into more details on what do we mean by data collection and multivariate data collections. Most of you will either do a survey or type, if you do quantitative work, okay? And that can be an extension of a two-phase studies. Sometimes we do a two-phase where we do a qualitative phase where we collect the items for the instrument, and then later on we dive into actually doing a pilot or a full study where we quantitatively measure those items and try to manipulate or see any variations or changes. So this is what I would like to talk briefly now. And then the issue of organizing the data. This is a massive area where we as professors, when you guys bring us the data originally, whatever you collect, it looks a mess. Okay, this is not something you can actually run any analysis on it, because you first need to organize your data before you even do the pre-analysis. Okay, I'll talk about pre-analysis as well. So that's another issue to look into. And so with that, we're going to look at two books. Of course, this multivariate that I talked before, and then we're going to start introducing also the PLS book that if you're interested, it is also on the RESD website. The RESD is 720 for the course that is coming in the winter. So if you're interested in getting that or writing the ISBN, it's on that website. So what's the idea behind it? The quote for this is essentially the art. It's the true art of the science. This is really where you get to be creative. And if you're creative enough and you're, have the right skills to develop those surveys or to develop those ways of preparing and capturing the data, you should be fine. And this is knowledge that all of you, if you're doing any work that has to do with surveys, or really should pay attention to and use it. And so I'll start with that. The idea here is essentially creating, you can call it a spreadsheet. We created in statistical analysis the matrix, right? The data matrix. It's exactly the same thing. This is what it is. It's just a spreadsheet of your data. The idea is that we take that data and it's actually used as a mathematical matrix to multiply and then develop the analysis based on that matrix, data matrix. So we'll talk about preparing a little bit of overview, then we'll talk about preparing. By the way, just so you know, there is a whole course that talks about matrix and matrix manipulations, and this is of course beyond the scope of our program. But just so you know it. Multivariate survey instrument, we'll talk about how to prepare that, how to collect the data, what are the types. Again, this is very, very quick. I'm sorry I'm talking too fast. And but that's the limitations here. And then we'll talk about collecting and organizing, and then we'll see. I'll leave the hands-on to the end if we have time, and if not, I'll talk to you about some time that I'll stay here for you to come back. So what are the issues of multivariate? Let's dive directly into this, saving time. Essentially, multivariate data matrix is a spreadsheet of pure data that you collect, okay, that you're going to have ultimately, and this is already clean, so ultimately, you're going to have the case ID, which represent every submission. So you're going to have a form, right, the survey. In the old days, you had a paper-based survey. We wrote in the back. I used to do that. In the back, we wrote a serial number for that survey, and we'll give them out, and then we'll collect them back, and based on that back number, we'll just record the data. And so based on that, we knew how many we gave, how many we got back, what was the response rate, which is the ratio of how many I got back versus how many I gave out, and it's always low, right? If you get 25-30%, you're lucky. If you are in a situation where you're the instructor, you have students in the class, and you demand, otherwise you don't release their final grade, then you might get 90-some%, okay? But I'm not going to go into the ethical side of it. But the idea is that every row in the data, so in the old days, we'll take that paper, we'll have a student assistant or someone who will sit down and actually do a data entry, right? On each rubric, we'll punch in the data. We don't need this anymore, right? We're creating those surveys very quickly, very easily, and the data goes directly into a file, which is really beautiful. You can either use some of the tools, there are available tools I used from my dissertation. I actually created an SQL survey that goes into an SQL database, and then that's how I collected all my data. Later on, there are tools, SurveyMonkey and some others that you can pay to get the data. Otherwise, they don't give you the data in that way. Okay? Google Forms will do it beautifully. So I'll show you in a moment. The idea here is that you have your variables. These are the variables, right? And these are simple variables, what you see right now, right? Gender, work hours, age, salary, educational level, let's say, whatever. But later on, we're going to go into more advanced ones. So there will be satisfaction, right? So satisfaction might be composed of 5 items. So it will be SAT 1, SAT 2, SAT 3, SAT 4, SAT 5, etc. Okay, so you're creating those, what we call items within the construct measure. So you have a measure, that's the latent variable, and then you have the items, the questions, the survey questions that represent those actual measures. And so we're going to have those, right? And then every person that will hit submit in the form will add at the bottom of your data, your data matrix. Okay, that's the idea. Right? And of course, your goal is to get as many as you can, right? So with that, let's talk about 2 types of measures. It's important to know that as well when we go into multivariate. There are 2 major types of measures, right? The direct and indirect. I'm not saying one is better than the other, right? It depends on what you're trying to measure. So there might be direct measures that will touch the metal in order to know the temperature, and there might be some other advanced pyrometer that will actually use the other means to measure the temperature. I'm not saying this is bad or this is bad. It depends on what you're measuring and how you're measuring. Now think about ice usage. Right? What we can measure ice usage as a direct. Can you think about a direct measure? 3 different direct measures for ice usage. Time you're spending, let's say it's an ERP system in an organization. What can you go and measure? Direct.
How long they were logged in.
Okay, logging in time, right? That might be one. What else? Is this the only measure that will show you usage?
Transactions.
Okay, number of transactions. What else I can measure?
Sessions.
Time of being away.
Time, reducing the time from that time. So you're gonna measure another one and then substitute. This gets us into the formative versus reflective, okay? Now you understand that there might be some that are competing or that you need to look into multiple pieces of the same one. We'll talk about this in a moment. But if I want to do an indirect, what will be an indirect for ice usage? An indirect way. Now let me ask you something else. What if we're talking about ice usage in the context, and we have a dissertation like that, on the area of cyber slacking?
Self-report.
Self-report, I'll ask you how many Facebook posts you did during work. Is this valid as an indirect?
Yeah, because shows that you're not doing work.
Yeah, but would your answer to that will be still valid? So when you deal with indirect, you also need to deal with the validity of the measure, right?
Yes.
But if I ask you how much your coworker spent on Facebook,
A lot of time.
you see what I'm saying? So you gotta deal, even with direct or indirect, you need to look into the different types of the measures within that.
Okay.
And that's crucial. You gotta think about that. You gotta think about how biased that will be. This will be biased to the lower, and that will be biased to the, like you answered, to the higher, right? So you gotta understand that as well. So maybe I'll throw in a couple of other measures that will give me a better picture of the truth, okay? But this is an important issue you gotta think of when you go into the multivariate, the issue of direct and indirect.
Suppose you analyze the audit log in order to figure out how much time
Right.
they were using.
Right, right. And so that might be it, right? But not necessarily. So for example, if you want to look into cyber slacking, okay, and you might have one computer that is infected with malware, and that broadcast all over the network with some porno sites, okay, then your measure is distorted. Okay? That's the issue. You gotta understand what goes behind the measures. And so when you design your study, when you design your own measures, you gotta think about those. Okay? That you need to look at, are they direct, are they indirect? If they're indirect, do they make sense? Okay? So when we go into latent variables, we actually look, as I mentioned before, that's the multi-item measures. This is where you're gonna measure things like trust, satisfaction, or in this case, we actually measured the issue of the personal information sharing. Okay, how much do they share information over Facebook? Okay, so what we did is we looked at and we built it on other measures in the field, and in this case, we only used 1 through 5. This is a dissertation that finished 2 years ago, I think. And so we looked at 5 items to measure the same thing. Okay, and then you will see how these might look very similar, but they're not exactly the same. And so this is where some of the multivariate analysis methods will help us determine which question is valid. Most of you are not aware of this, and you think, but this looks so, they look the same, they're almost the same. Why do I need 5? Let me just slash some. But you don't get it, that they all add up to what we call the cohesiveness of that construct, latent variables, which we measure basically by the validity, and I'm going to go into this later, the Cronbach alpha. And that Cronbach alpha is a statistical, mathematical way to tell us which of these items are actually adding to the validity of to the reliability, of that construct. How reliable is that construct? Now, what does it mean reliable? I'll mention to you very quickly so you get this, and that will resonate in your head. This is something I had my multivariate professor teaching me. And the idea is very simple. Think about a measure that I'm going to go and measure this can, okay? And I want to measure how many inches this can is. Now, I can come with a ruler that is very rigid, and so I'm going to measure it, and it will give me a number, let's say 4 inches. And I'm going to come with a rubber band ruler, and I'm going to stretch the rubber band and measure it, and it will be only 2 inches. That is the reliability of that measure. How reliable the measure is, meaning how I can repeat the measure and get the same. So if I change rubber band, it will change the measure. The idea is to make sure that your measure is rigid enough that no matter what you're going to measure, no matter what context, it will measure the same thing. Of course, if you're going to take that ruler and throw it into a very hot area, it's not going to be valid anymore. It's the same thing with those measures. You got to understand the limitations and boundaries. So when we look at those latent variables, so we're going to have, again, coming back in here in a more advanced multivariate data matrix, you're going to have this case IDs and these measures in here that we collected. And so essentially what we're going to build up is something like this based on it, right? So it will be based on that. And that is what latent variables are. And so there are 2 types of latent variables. We mentioned this before, and I want to run quickly so we can get to the more interesting stuff. So we have a reflective type of variables, and then we have also the formative. And majority of the construct that you will see in information systems will be more formative, okay? In other fields, there will be more of reflective, and I'll talk about this as well. Think about the measure of iPhone. If I tell you an iPhone, what do you think? You think about the front, the side, the back. You think about different views, right, of the same thing, right? And this is essentially what reflective is, okay? Versus if you look at formative, right, there will be the pieces of it combined. So think about it as different views of the same thing represent the reflective, and then the formative will be the pieces of combined. Okay, and so essentially what they're represented in those models will be either pointing out, and this is nice to remember that it's a reflective, right? It reflects out, so it's reflective, versus if it's formative, it goes into as the pieces. So think about that as the views in the parts, and I'm giving you here some ideas of how it represents. This book is all about this. It talks about 2-3 chapters are covering this, the differences and the issues related to the analysis that comes in mind. So if you're interested into learning more about this, of course, there is a limit to how much we can cover here. So with that, I want to shift gear quickly into preparing your actual survey and collecting the data. So after you have reached a point, usually in the dissertation stage, we get to pass the proposal. This is where you have your committee signed on your study, on your measure. They know exactly your survey. They know exactly what methodology you're going to use. They agree that this is valid to the extent possible. Of course, things happen, and sometimes we need to change things. But the idea is that you already have that. You already have also approval of an IRB. Okay, I'll mention that later. But you can start developing this and experiment with this before the IRB, as long as you don't approach people to submit your survey. Okay, so the idea is to use Google and to create there. And there are a couple of steps on this slide. Essentially, you're creating a form. The form, based on the design of the form, will create the data matrix, which is neat. You don't need to do anything. You just need to, besides one thing, you gotta click on where it says choose response destination, and then tell it create a new file. This is the name, and that's it. It creates the matrix for you. Really neat. Okay. What you need to understand, and this is something you need to experiment on your own. Okay, is the type of survey questions and the scale. Now we use the word scale to represent how you're gonna ask the users to answer. Is it from 1 to 5? Is it the dual? Is it different types of scaling? The Likert type is a scale. Okay. They use the word scale to represent one of the types. Okay, which happens to be similar to the scale that we're talking about, but that's not precisely the same thing. So pay attention to that as well. These are the different types that we have. The idea is that you create, in the scale type, you create those from 1 to 7 or from 1 to 5, and this is how it looks on the form. So this is how, when you design the form, when you edit the form, this is how it looks when you are creating the form itself to view by the user. So if I like using fingerprint biometrics, and that will be from 1 to 7, and of course I made sure that the question is required. Why is that?
Cannot skip.
They can skip. You're going to get what in your data?
So you can collect the data.
Exactly. What happens if you didn't check that? You're going to have missing data.
Yes.
We'll talk about that in a moment. That's a very big problem in multivariate data collection. So make sure that you're aware that you check that. I'll talk about other issues that we have in the data collection in a moment. And the idea is to get the data in the matrix, and this is the view that you will get in the matrix itself. So essentially, you get the name of the variable that you put plus this. Okay? Same thing, similar thing you're going to have for the grid, which the grid is where you have, and that's also a way that we're collecting data mostly, and you're going to have the names, so you can actually create the text, which is also nice, so users will know exactly what each represent. There is a lot of research about that as well. And then the data received is this way. Now, if you use a quick in Excel replace, you can just replace those quickly to just numerical values and then output it into either leave it as Excel or output to CSV and then import it to SPSS. We'll talk about that in a moment as well. Okay? So the process is very simple, relatively, but you gotta play with that. You gotta understand that whatever you're gonna design, if you miss some things, you're gonna be in trouble. We'll talk about it in a second. So this is what I call to develop the more-proof survey. Okay? And why it needs to be a more-proof survey is that so you get anyone to read your survey and they will completely understand exactly what you want to measure. Otherwise, you're in trouble. Okay? So this is where I put the more meter here, and we're in trouble. Average, getting there in Einstein is the top, right? And so think about it. Every time you go to design any survey, because this is crucial, if your instructions are incorrect, you're going to have bad data. And you're not going to be able to validate anything. Okay? That's one thing. So this is crucial, the idea here. So what do we do against this? We do expert panels. You will see that most of my students will go through expert panel if it's a survey. So experts will review their surveys. We'll give them feedback. We'll tell them, hey, that doesn't make sense. You know, the instructions here, you just cut and pasted the same instructions and it doesn't make sense now. Okay, or things like that. Proofread your things. Sometimes we have the same questions repeated by mistake. Or, even worse than that, we had a guy who forgot, who actually edited the survey the night before he sent it out to 5,000 people and deleted 3 variables from the survey. Guess what? You have only one shot. You're not going to be able to go into 5,000 people and ask them to redo your survey. It's impossible. It doesn't look good on you. And most organizations won't allow you to do more than one shot. Right? You're wasting the employees' time anyway. So you got to be very careful. You got to do very extensive pilot testing to your work. Any instrument that you're going to collect data, if you don't spend the time thoroughly to test it, you're going to be in trouble. So with that, what do you get actually? So let's say you send it and you got people and you're sitting there nervous and you're looking at your data matrix and you hit refresh, and you see how the numbers adds up, hopefully, right? And then they stop. And then you freak out, right? It stopped at 27. That's nothing. You promised your committee that you're going to have 250. That's reality, right? And so there are techniques to send out reminders or different ways of increasing your response. And I'm not going to dive into it, but essentially you get this, okay? And so with this, you cannot run any analysis, okay? You got to do some preparatory organizations to it in order for you to put it into SPSS. Even before, you need to get it into Excel. So the best way I recommend, this is what I recommend all my students, is you get the data, right? The data matrix from the survey, raw data. First of all, you name the files. Those of you who work with me, you know I'm freaked out about naming of files. Why? Because once you start developing all these data files, you're going to be lost. In 3 days, you might develop 30, 40 files. You won't remember which one is which. Okay, one with the Milano businesses, one with the outlier, one without the outlier, one with clean records, one without clean records. You're going to be completely lost. Completely. You won't be able if you don't track it properly. The idea is to import it first into Excel. Massage a little bit that data to prepare it. And this is what we call organizing the data. So you need to organize your numbers, that there are numerical values, that there are no strings, no spaces, no nothing in there, no strings related to it. You need to name the variables, that it will make sense. And these namings, those of you who are taking, doing the dissertation with me, you know that when you reach the idea paper, we work on naming of your items within the survey. So in the appendix of your idea paper, you're going to have the survey. In the survey, I want to see the naming of each item. And the naming needs to represent, A, what is the construct, and what is either numerical value or something to it. So it might be the habit, right, on social networking tools, and then that's measure B was for something else. This is post-test, okay, for B. A was pre-test. Okay, so we measured 1, 2, 3, and then a different variable, 1, 2, and 3, and then a different variable, 1, 2, and 3, and these are all post because of the B. So the numerical represents something. There is a limitation in SPSS when you import data. I think they expanded from 8 to 10 characters. I stick to 8. So if you make these short enough, and this should be short, you should have no problem when you import it to SPSS. The other important thing is to add the case ID. The case ID is important, okay? Because we're going to run some analysis, the pre-analysis. We'll need to identify outliers. We'll need to identify some problematic cases. How would we know which case is which? By this, okay? So each case is your submission. Don't forget, each case is an individual, if you will, that submitted your records, okay? So you got to number them, and that is easily done in Excel. So I'll do that in Excel, prepare all the data, and essentially now it's ready to import into SPSS. And when we import it into SPSS, we have two areas. We have, this is the usual standard. If you want to open up SPSS on those machines, you can do that. But essentially, what you get is you get the two views, the data view, which we'll look at it in a moment, and the variable view. You need to organize the variable view first before you run any analysis. Okay, you got to look into this. I will talk briefly about what do we do before we even import. There is a step, and then we import the visual inspection. We'll talk about that in a moment. The idea is to look into what type of a measure it is. Okay, and this should be street, for example. It's a mistake. These are ordinal. Gender might be nominal. Okay, you need to look into these and set them up. They don't come automatically. Sometimes it detects some of them. Sometimes, most of the cases, it's not. So you gotta adjust these. You gotta adjust the decimals if you don't want to see them. You gotta adjust the width, etc. And then, of course, the name. You can either leave it as it is, or you can label them. And so you can create a label. So when the analysis is done, it will tell you the label of that variable. I prefer to leave it as it is because my original naming of the variable tells me a lot. Okay, so that's another way of doing this. And of course, once you click on the data view, you get the data matrix. Okay, and that will show you your data in there. One thing you're going to be able to see is that if you're having any missing data in SPSS, you're going to get a dot in that rubric. Okay, in that cell, we'll have a dot in it. And the idea is that at this point, it's actually your data is ready to start, not analysis, pre-analysis. Okay? So we'll talk about that quickly now. Wow, I'm running out of time. Quickly. Pre-analysis is one of the most significant areas that I think in any analysis must be looked at. And so this is where we do some screening of the data before. One of the biggest issues I see is that students, particularly doctoral students, don't spend the time to really know their data, okay? They don't stay enough to understand the data, to know what their data looks like, to visually inspect their data, right? Think about this, you're running into the analysis, you get the results, and then you spend hours looking at the results instead of looking first at your data itself. Understand if there are any problems there, and this is really the key here. So what are we looking at? We're looking at, the idea is that garbage in, garbage out. Very simple. If you're not going to inspect your data properly, if you're not going to run some free frequencies to identify how many missing records you have. Simple things. Just going into SPSS, running analyze frequencies, explore frequencies, and just know your data. See what's the mean. See what's the minimum and maximum. Now, if I have a minimum of -7 and a maximum of 26, and my scale for the measure is from 1 to 7, does it make sense to you? Right? That's what I'm talking about. But that will skew all my analysis. Simple things like that you gotta do before you run into bada bing, bada boom type of analysis, and then you're getting things that don't make sense necessarily. So
How
let's
you
talk
fix it?
briefly on the issue of
If you find that discrepancy, I just say how you fix it. Or you go back?
well, that's a good question. So what happens if you have missing data?
Yeah.
Okay? Missing data is one of the biggest issues. I'll talk about it in a minute. I have a slide on that. There are ways to correct it. Okay? The issue is when you have minimum and maximum. Check it out. It might be an error in your form.
Okay.
Maybe when you design the form, you set it up that instead of 2, it punched in 27 on all the records. So you go back to your survey and you start identifying, I have 17 cases that has 27 as their core. So you go to your survey and you look in there, and maybe instead of the 2, you type 27, and so you do replace, and you replace all the 27 to 2. That's one example of that.
But
Okay?
do you report it in your findings? You know.
No, you don't need to report it. This is a process that you do for yourself. There are certain things that you will report, outliers.
Okay.
Because if you're going to take out a complete case,
Yeah.
you collected 284 cases, and here you go, all your analysis is on 232. Where are these 2 missing? Right?
Okay.
Cases missing. We'll talk about that. So this in terms of that. Missing data is of course an issue I just mentioned before. The issue is that, is this missing data random or non-random? Okay, if this is a case where you might have one item that it happened that you forgot to check the required in the survey, and occasionally, here and there, out of 300, you have 6, 7, 10, 20, 30 even, if it's random, right? It's not based on a reason beyond the survey thing. Then there is a way for us to do what we call missing data imputation. SPSS has a module called missing data. It's additional module. I don't think it comes with the version 21. It's possible. I have that. It imputes data. What it does is it takes all the rest. It's like bootstrapping. It takes all the rest and try to identify what others who rank the same on all other cases mark that. So it's kind of a classification method, and it actually calculates, imputes that, and you get a new variable in that cell, which is really cool. And then you run the whole analysis if your analysis is not robust enough to obey the missing data. There are analyses that will be okay with certain 10%, 15% missing data. It depends on that type of analysis. By and large, I'll tell you, my philosophy is don't have any missing data, right? That's the best. If it's non-random, and by non-random I mean you missed a whole variable, or you missed a whole item in a latent variable, then you're in trouble. Then there is no way for us to impute that data. It's very, very difficult. Okay, and there is discussion about that. I'm not going to go into this, about how to validate, even if you're missing, you better have it. That's the best. Okay? Another area is response set. This is a big problem. We have, especially those of you who are going to survey students. They go in, they mark everything 3 from the top to the bottom. Okay? This is where you need to know your data. You gotta live with your data for a while. Get married to your data for 2-3 weeks, so you really know it inside out, right? So if you have someone who marked everything 7, you gotta recognize that. Maybe you need to take that out. Maybe it's not valid at all, right? Maybe you run the analysis with it and without it. We'll talk about the running analysis with and without in a moment when we talk about outliers. So that's something to consider. How many of those do you have? If you got 1%, it's not a big deal, but if you have a high percentage, 2 digits, then you're in trouble. You need to look into what to do with that. Of course, if you have 700 cases and you drop 10, it's not a big deal. But if you have 150 and you drop 10, it's an issue. Right? It depends also on the robustness of the tool. So, the idea is that you guys need to be aware of those issues before. One of the crucial areas is multivariate outlier. And it's easier to think about an outlier in the case of univariate. You have a group of data. Let's say the normal distribution is 3 standard deviations, right? Remember the bell shape, right? Plus and minus 3 standard deviation. And here you have a case that is 7 standard deviation plus or minus out. Obviously, that's an outlier. You need to deal with that. Okay? That's easy when you have one variable. What happens when you have a group of 40 some variables, right? And you are trying to identify the multivariate for that group of variables. And the idea in multivariate outliers is to take only your core measures. So this is where we're going to do an analysis. I'll show you this in a moment. I'll give you the cheat sheet for Mahalanobis distance is the one to do it. It's really simple, very easy, but it helps a lot. You need to identify those outliers, and it tells you who they are by the cases, but you need to understand it before you run the analysis. Okay, so you deal with that before and you identify. So as I mentioned before, the idea is to overcome that. The idea is to identify those what we call bad boys, right, that are completely off, and to understand before with or without it. And of course, transformations of normality and linearity and heterodicity are helping us as well. These are important things when we go to the tools. So quickly, what are we getting? The lowest, we're not concerned with that. These are the inner area of the bell shape, how they're closed. We care about those that are completely away from the outside the 3 standard deviations. So we'll only look at the highest ones, right? And we'll look at the values. And these we'll identify. And I'll show you quickly. We produce a very nice graph. SPSS produced for you. I actually gave you the cheat sheet of the steps to do that. We're going to do this in a moment if we have time. And so you take this, your data, you take all the variables that are valid measures, not the demographics, not including the demographics, okay? Just the measures that you're using, you throw them all in, and you tell it, okay, identify for me the cases, and you label the case, and tell me that case, that row, that is the multivariate outlier for the whole group. And so we'll calculate the Mahalanobis distance, which is essentially, if you can visualize the distance of the error from the centroid of the group of all points, if you think about it in 3 dimensions, right? Here it's 40, so it's tough for us to explain. And then it will plot it for us and give us also values. Now this is art. This is not science. This is where you really need to look into it and understand, okay, what does it mean? Is it really far? How many cases do I have? You don't just run to eliminate those cases. Okay, this is where the art piece is. This is sometimes where you need to tweak a little bit. Run the analysis, the end analysis. Tweak it with, without. This is what these people that you see published in top journals have done all throughout in order to get those beautiful, right, results sometimes. These are the things we need to do.
Quick question.
Yes.
If you just eliminate the beyond 3 distributions, you have the options as SPSS. That wouldn't be a clean, easy, quick way to do it?
No.
Okay.
You don't eliminate just records.
Okay.
You need to understand what it means and what type of, and what value. For example, if you have done that, just eliminate all records, I would have eliminated here at least 6 or 7 cases that are valid for me. They're okay.
Sure.
There might be a 3.15 standard deviation. I'm okay with that. I'm fine with these. But I'm concerned with those that are way higher. And maybe I'm going to remove only this and not these. Okay, again, this is where the art is. You don't just It's not black and white. That's what I'm saying, okay? Another big area is the multivariate reliability. And I mentioned this before. This is known as Cronbach alpha, but Cronbach alpha is one way of measuring multivariate reliability. I'm not going to go into definitions and all that. Essentially, what Cronbach found back in the 50s is came out with this equation. I'm not going to go into diving into this. You can spend, I have the original 1951 paper if you want. The idea is to calculate how a group of measures are measuring it from a different perspective, grouped together as a cohesive measure. And this is almost every IS paper that you're going to meet now that is using latent constructs will have this reported on each and every separate construct. So they might have a table with the list of the constructs. If you look at any dissertations that I chaired, they will have a table with the list of the name, satisfaction, computer self-efficacy, whatever, all these, and then reported how many items in there sometimes, and the Cronbach alpha. The reason we report how many items, I'm not going to go into the math, but the idea is that it is dependent by n, and n is also dependent by the number of how much you add variability. Bottom line is that the more items you have, the higher the Cronbach alpha is. Okay? So if you have an item that is measured by 15 items, by nature it's a large measure, not necessarily a good one. I prefer to have the same level of Cronbach alpha with a measure that has 3 items than a measure that has 17 items. If they have exactly the same Cronbach alpha, that means that these 3 are really nailing it. Okay, that's the crucial piece in here. And there is discussion regarding the cutoff point, what is good, what is excellent, what is whatever. You can look into this. Different papers report different things based on whatever their record is. I'm going to go in there, but the idea is to develop these. And there is something else nice about SPSS. And we'll see if we can hit that. SPSS will allow us to actually go in and not just know the Cronbach alpha of the whole latent variable. It will allow us to go and know the Cronbach alpha of that latent variable if I deleted each one. Okay, this is key here. A lot of people don't know it, don't use it. I wrote about this in multiple papers. People don't pay attention to this. You run the Cronbach alpha for the construct, and then you check what is called if item is deleted. There is a checkbox in SPSS that you got to check, and it will tell you what will be the reliability of that same construct if I took out that item. Now, what does it mean? It means that if I actually created a construct without that item and the Cronbach alpha goes up, that item is bad. If I remove that item and the Cronbach alpha of that construct goes down, that means that that item is important for that group, right? And so that gives us more assurance on the reliability, not just of the construct, of each item by itself. So when we do exploratory work, when we do exploratory factor analysis, for example, we create those factors, right? When we create the factors, we are going to look into each and every item, and we're going to check what happens if we pull them out. If I pull out some items and the overall Cronbach alpha for that factor goes up, that is a problematic item. Okay? And so you need to explore it. So that's part of the exploration phase. So I'm going to look into it. Here an example. This is the Cronbach alpha for the whole construct, just computer misuse. Okay? And then we're going to look into, this one is 869. So if I remove it, it goes down, right? This is 803. If I remove number 2, it goes down. So these 2 are fine. If I remove this one, it's 862. It's also going down. But if I remove the 4th one, it goes up to 0.899 versus 876. So that tells me, and of course if I take this one, notice how much it drops. So this is probably a very significant question out of the group, right? In terms of reliability, and this is probably a problematic one. Maybe the wording of that specific item, that specific question in the survey was not accurate, was confusing to the users, to the participants. these are areas that you need to look into, and that will tell us, should we take it out before we go further to analysis? Or what do we need to do with that? Yes?
So this would be something that you would look at in your pilot testing?
No, this is something that you already have the data. Hopefully you can do it in your pilot testing if you
Okay.
do stage, yes. If
Yeah.
you do the stages of pilot testing and you have enough data. The problem is that most people do pilot testing, they collect 20, 30 records,
Right.
and that's not going to be enough.
Mm.
Okay? That's the problem. So what happens if I go and I take it, I actually go and remove that, and I increase it. If you do a real advanced pilot testing, exactly, that should help you. And sometimes your whole study is about exploratory. We have studies, we had a couple of dissertations that we completed that are completely exploratory. Their whole process is to try to identify those. We actually had a dissertation, and there is a poster over there regarding the computer security self-efficacy construct. The idea was to develop those sub-factors, latent factors that will represent, but find the right items. And this is the process that we did, okay, to find the right items in there that will represent this, okay? We can stop here and do some hands-on, or I can go and do an overview of some multivariate analyses, talk about ANOVA and COVAs, down into multiple variate regression, down into structural equation modeling. Which one?
Whatever.
I can leave time. I'm going to be here after lunch if you want to come back to here, and then we'll do some hands-on.
Yes.
If
Okay.
that's better for you, then
Yes.
we can capture that as well, because my time is, as I told you, I'm
Yeah.
trying to run here 6 hours worth of work into 2 hours, which less than 2 hours. Okay. So the idea here is to, I want to talk about some overview of multivariate data analysis, the actual statistical analysis that we're going to use, assuming that you went through the process, that you captured the data, that, of course, all the preliminary work on your dissertation, and then you got to a point where you are able to do that. In this case, I'm recommending an online book. It's actually a textbook that you can actually get it also in print through Amazon. It's available online, so use the online version. They have a competing tool to SPSS, but it does exactly the same thing. Okay, so you can use the same ideas from here. Almost all the advanced multivariate statistical analysis are listed there, very elaborated. So if you're into path analysis or discriminant analysis or principal component factor, exploratory factor analysis, confirmatory factor, everything is really detailed in there, okay? And you can cite the book, of course, in your dissertation, which is nice because it comes in print as well. It's not just a website. So you have it on the slides for the presentation. The idea here is that when you do multiple variate analysis is not to quit. Most people quit too early when they do analysis. Okay? They get one result or two results and they say, okay, that's it, I found something, let me try to understand it. No. Try to stick to it and try again and again and again, different types, different methodologies. I have most of my students go through and they do multiple types, even not written in the dissertation. And sometimes we get exactly the same results. The most significant factors impacting or other results, they come up. It doesn't matter what tool you're using, you get almost the same results. As a matter of fact, we had a couple of dissertations where we tried nonlinear regression, ordinal regression with multiple linear regression because the violation issue, we got exactly the same results. So these things happen all the time. I'll talk about some issues of confirmatory versus exploratory now. I think it's important. There are two major philosophies that you need to think about yourself. When you go to conduct your own research, think about the two areas. Is my work a confirmatory or my work is exploratory? Now, some of you might combine the two, and that's extensive. Some of you will stick to one, okay? And so if you look into exploratory, you look into a phenomena that was not fully developed, that there are no, to your knowledge, that there are no established constructs, measures, surveys, or other ways to measure things. And so you're trying to develop the measures. You're trying to, like we talked before, the process of the Cronbach eliminations and things like that. In confirmatories, where you have a theory, you have a conceptual map, and you're saying, I'm going to take this concept map, this is the map I have, I'm going to go and collect data, and then see how best the theory fit that model, the data fit that theory. Okay, that's the idea. And most of you do that. Most of you go and you have a conceptual map, and you want to validate if that makes sense. Okay? The idea here is not to get confused. This is always the case. The idea here is that when you do those model testing, you need to get the model itself. If you run structural equation modeling, for example, you need to make sure that your model is not significant. And this is always throwing people off. What do you mean by not significant? Always I'm looking for significant, right? The idea is that your theory and your data are not significantly different. If they are significantly different, then your data and theory don't match. You got it? Okay, so in structural equation modeling, the true one that you run through advanced, let's say, Amos or other advanced non-linear necessarily, not the PLS, for example, you will get those specific indicators. I'll talk about that. This is where you need to make sure that your model is not significantly different. Otherwise, your model and theory is different. And that's the idea here in the pregnancy test, right? You want to make sure that your results are really what they represent, right? Whatever you found is really that. So if you're looking for which factor is impacting, if you're looking at impacting, then you need to look at significant, etc. I want to touch on two slides that are very important. These are slides that you really need to know. They're coming from this book. Okay, they're at the beginning, chapter 1, I think, and they're very crucial. As you guys work on your idea papers and designing your own research study, you need to look into these. And some of the information here is missing because it's not purely for information systems. It's more for educational research, but it's still good, or social sciences, but it's still good enough for us as a starting, and I added some things. The idea is, how many variables do you have and what type of variables do you have? How many independent variables, how many dependent variables, and do you have any covariates there? And so this table will help you based on the number of what categories you have on the variables and what type, how many variables you have. You have one, of course, almost every information systems research will not have just one independent variable. You're going to automatically be in here, right? So multiple. You're going to have multiple independent variables, and then you're going to look at what type of dependent variable. This is assuming that you have only one, right? When you have multiple of them, several dependent variables, there are very few. So this is more for the one dependent variable. This is more for the multiple. Notice that when we get to the multiple dependent variables, there is some holes in here. Well, of course, this is where the confirmatory factor analysis, PLS, and the structural equation modeling, the true one, will fill in the gap. This is essentially what it is. These are the areas that you will fill. So you need to look at your own hypothesized model, or what type of hypotheses you have, and fit that within the type of analysis that you're looking for. This is another representation looking at the degree of the relationship or group differences. This is crucial. For example, yes?
On the previous slide, median
Yes.
variables, are they not a consideration? Is it
They're
just-
not. This is not typical in the educational, typical social sciences. For us in information systems, this is where it will link into structural equation modeling and PLS type of. So if you have those, if you're looking for those, then this is where you probably go into.
Okay.
Okay? Or you're looking at the covariates, right? It depends on how exactly you're stating the hypotheses. What's nice about this book is it has examples of hypotheses, example of research questions for each different type of research methodology, they give you examples of research questions and examples of hypotheses. So you really see how they structure those. I throw in a couple in a moment, but the idea is this. Think about your research, and some of you guys are here mixing up. And I know, and I did it on purpose, and that's okay. In presentations, at this point, you really need to think thoroughly about your research. If you're still in the design, is your research looking at degrees of relationship? You're looking at impacts. You're looking at this, how significant one factor impacting another. Or are you measuring group differences? Do you have two groups, before and after, or two types of experiments, or things like that? Then this is where it splits. Now, some of these will be, some of the methodologies will be okay for this and this, depends. But some of these areas you gotta pay attention. Then it goes into what type of dependent variable and independent variable, etc., etc. It's a nice decision tree to quickly help you. And there are even online tools. I know Dr. Ellis has on his website a link to an online tool that will help you understand where you are fitting and what type of analysis. The problem is that, again, this is not an information systems. So when you get to this rubric, down here, it might tell you, sorry, there is no analysis that we can do use for that. We already have it. Okay, we know these are the advanced structural equation modeling and the PLS and the other more advanced things. Another area that you look into is the type of research question. Again, I'm not going to go into this, but the type of categories of the dependent variables and things like that, that will impact the type of specific analysis that you're going to select. So with that, simple example. Here is an example of a research study from that book that talks about, I altered it a little bit, that talks about group differences. So here we have a factorial design. So we have females, we have the males of male, female. We have the computing skills level. So we might have 5 computing skills levels. And then we have inside the productivity level of whatever we measure for that subgroup, okay? So this is within category, right? And then these are some examples for research questions. And the idea is to try and look for any significant differences here, any significant differences this way, any significant differences on the interaction of 2 or more variables. And again, this is more advanced. I'm just touching on even the tip of the ice, right? And the idea is to create those drawings or graphs that will tell us, when we calculate the means of each group, how they interact or how they relate. So in here you will see that no interactions in here, that essentially they will have some sort of an interaction, right? It's the other way around. And in here is what is called disordered interactions. Is essentially it's crossing somewhere in the middle, right? And of course SPSS gives us all those results, and we can also look at the interaction, and this is what it means that we look. Interaction effect is when we look at the combination of 2 variables together, okay? So when we multiply the 2 variables and how they interact, and of course SPSS gives us the F statistics and the significance level of each and every one. So in here, for example, you will see these are 2 significant levels that are significant, and this one, the interaction is not significant in this case. Now one caveat on SPSS, and this I see all the time, I get results in dissertations, they write me P, which signifies the significance level, P level equal 0. There is no such a thing, okay? It's asymptotic. This, what you see, it's a rounding. SPSS rounds the P. This is actually .0, and there is a 1 or a 7 or whatever somewhere. There is no such a thing as a P equals 0, okay? That's a basic thing, so just be aware of what it means. What this means is, of course, the lower it is, the stronger the whatever. If this is an association, or if this is an impact, or if this is a coefficient, how important that coefficient is, and that will give us that level. And from that, you can, of course, plot these and get these interesting graphs that will demonstrate for us. But these are all the ANOVAs and all that. And when we go to ANCOVAs, it's essentially the same thing, but controlling for one thing. So in here, I'll do exactly the same thing, but I'm controlling for, let's say, educational level in this example, okay? So I'm giving you some examples of research questions, or you can convert those to hypotheses as well. And then analysis will look something like that. I'm not gonna spend more time into this, but the idea is to try and find those that sometimes the interactions, and in here you're gonna get three-way interactions, and that might be, in this case, right, it's not significant because we're looking for below two tails. And by the way, one tail versus two tail, we most likely in our field using two tail because it's kind of related to the number of variables that you have in the analysis. So assume always the two tail that you're looking at. Again, I'm running here at 200 miles an hour. Multiple linear regression, you all remember this. It's very simple in 2 dimensions. Y, right, equal to a combination of ax plus b. When we take it into multiple dimensions, we might have factors, and we're going to create factor analysis and create some kind of a mathematical algorithm to combine these and then see how each is impacting the dependent variable. This is a simple multiple linear regression, and of course we can throw in the covariates or the control variables, and that is not is a bit different. I'm not going to touch that, but we can do that as well. The idea is that we create some sort of a linear combination in here in 3-dimension plane of all the dots that are usually not in a linear form to create this combination of y in terms of all these variables that we have. Now this is a crucial thing. These variables are data. So if you're dealing with latent variables, you need to create something to convert them. If you're using multiple linear regression or other types of regression, your latent variables needs to be calculated. Okay, you can this tool will not use latent variables. Okay, it's not like PLS or a structural equation modeling, the full one that will do that for you. So that's another thing. The idea is that we're looking, and the idea in here is that the dependent variable is, of course, a factor of the weights. And the weights, we call them in linear regression the coefficients, right? And so we're looking at the coefficient, how strong they are, and the sign, right? If it's plus or minus. So if I have a factor that is resistance to use, right? Resistance to use information systems, and the coefficient is plus on, just thinking what, right, on usability. So if the resistance, the coefficient for the resistance is plus on usability, that tells me that as I increase the resistance, the usability goes up. Does it make sense? No. You probably want to have a coefficient with a negative sign in front of it. We just had a dissertation that we had a problem in the data because it was not cleaned properly, where we got to a point where it was the other way around. That didn't make sense. And that's where you sometimes start to roll back and say, hey, did you do this? Did you do that? And then you figure out that not everything was accordingly. And so maybe the data was incorrectly entered. And so the idea is to look at the strength, the sign, plus is it significant. We talked about it in my session yesterday about is it significant or not, right? You might have here a coefficient that is high, but it's not significant. So if you get the coefficient, that's okay, but it doesn't give you a lot. It doesn't carry any variability if the significance is very, very low. And those are the things that you need to take in combination. Don't forget one thing. This is linear, as you can see from the equation. It's a linear combination. It might be 40 items in there, but it's still linear. So there are assumptions you got to make sure that you don't violate. There are ways, and this is, of course, the SPSS results for that. I'm not going to go into that, but one idea that you need to look into is that in regressions, we're looking to this R squared, which tells us how much variability all your independent variables are contributing in the dependent variable. So what do we do when it's not linear? Well, it's not the end of the world. We have nonlinear regression models. One of them is what I love to use, is the ordinal regression. And the ordinal logistic regression is actually something very neat in SPSS, and it produces very nice results. What's nice about the ordinal logistic regression, it's a type of ordinal regression that uses logistics as an underlying feature. It does not need all the assumptions of linearity and normality, which is neat. So you eliminate the worry about those, okay? Essentially what it is, and we run this in multiple dissertations, we looked at the implementation success. For example, this is the data we collected from NASA centers on the centralized identification system. We published this in a conference and then in a journal. And the idea was looking at the user resistance, user involvement, and computer self-efficacy. And the idea in here is essentially to create a linear combination of the independent variables to classify the probability of the dependent variables. So it's a mouthful, but essentially what it is we're classifying into categories, and the interval of classifications, what you're getting out of it is very similar. You get an estimate, which is your coefficient. You will see how resistance came out negative, small, but negative, and how the significant level is reported as well. Okay? And so these are the type of regular regression types. Then we go into the exploratory. Quickly, I will touch the exploratory and then confirmatory. Exploratory factor analysis, the idea is to create, and this links to this face recognition is all based on that, on principal component analysis. The idea, let's see if it's working, it is. Okay, the idea is to look at all your data in the n dimension of variables that you have collected. And the idea is to rotate the data. This is what in principal component analysis we use the word rotation, right? You might read a paper that talks about Varimax rotation, right? That is most commonly used. The rotation is the idea that you take all this data, you throw it into this n dimension, you rotate the data like you see here, until you hit the spot where the groups of the items are separated enough that the differences between each point to the centroid of another group is distinct enough. So there is no point that is exactly the same length between two centroids. Otherwise, it's a problematic item, like we talked with the Cronbach alphas, right? So you want to twist it and rotate it in a way that you might get separate groups. Now here is cheating, because this is an image that I stole off the internet, and they already painted the dots in colors. So it's cheating because you already can identify groups. But if I throw all these together and they're not painted, it's very tough to identify those. And this is only 3 dimensions. What if you have 40 dimensions, right? And you are trying to collect how many? 4.
4, yeah.
4 constructs or 4 variables, right? Factors. That's the idea. So we're going to rotate the data, and so we need to experiment. This is the experimentation phase. You experiment. The idea that you want to go and you have a pre-notion that this is how it looks, it's already confirmatory. Okay, that's the main difference here. So you already know the identified centroid. Okay, that's the idea. And essentially what it is you're taking all these list of items. For example, we did a study on information quality on e-government systems. We wanted to identify all the crucial characteristics of the system that contribute to information quality and group them into factors. And so we'll list all this. In this case, it's another study. I think this has to do with something as responsibility factors in something else. And so essentially what you get out of the principal component analysis is you get these blocks. And these are loadings. I'm not going to elaborate on this. These are called factor loadings. And we're trying, these are, if you can think about it as the distance from a centroid. And so you want to get the ones that are, it's actually the correlation of the distance. So it's the other way around. The higher numbers are there. And that's essentially what exploratory factor analysis, finding those groups, those factors. Partial least squared, the idea is very similar to linear regression. But in multiple linear regression, you're dealing with those variables per se, numbers. You need the variables in order to calculate that. In PLS, for example, you can work with the latent variables, so you don't need to establish that. So the plane that you're developing is creating the least amount of errors, right? This is where the name is coming from, to create those planes or bubbles, or in more dimensions, it's more complex for us to see, that will represent a latent variable, if you will, a factor per se. And then this is very common now in information systems. A lot of work is done on PLS and variations of PLS. This is some work that we did, the same work that I showed you before on PLS, for example. And so you will see that in multiple linear regression, we cannot do this relationship, for example. When we throw it to PLS, we can do those things. We can investigate how these. We'll need to do it on a separate analysis, and then there are assumptions and other problems. So, and then you get the results. And the last is, of course, that I want to touch on is the structural equation modeling, the complete one that is more advanced than PLS. Although nowadays some people argue that PLS can produce close to SEM, and it's considered PLS SEM. It's actually the title of the book is PLS SEM. But the idea in here is to develop those models in a non-linear basis. The basis of PLS is essentially linear regression on the covariate matrix. I'm not going to go again into the statistics, but in the structural equation modeling, it's even more robust than that. Okay, so this is where you're going to get measures, and there in PLS we get only the R squared, the strength of the coefficients, how strong they are in significance. In this, we get all that, but we also get the model fit. And this is where we go into the set of model fit indexes that you're going to see in some good papers talking about the goodness of fit, adjusted goodness of fit, and all the other goodness of fit measures. This is very robust and sometimes very complex. And we did some of this work. This is the adjusted thumb that we did way back. And so you report things like that. Right? You're reporting the results as if it's significant or not, and the overall model. And I'm not going to go into the details. We're out of time. I will be here after I'm supposed to be in the luncheon already. At 2 o'clock, from 2 to 4, I'll be here. If you want to come back, I know you have some sessions. But if you want to come back here, I will be here. I'll have my computer and SPSS. We can play a little bit and use those. I give you 2 data sets. One in Excel to play a little bit with the data organization. And then another one that is already in SPSS format that you can import and actually start do pre-analysis. So we can play, for example, do a Cronbach alpha and some Malabis distance and other stuff like that if you wish. You can come back and do that. If you want me to show you something else, I'll be more than happy to do that. Okay? Sorry about the speed and how fast, but there is a lot of information we need to cover.
Thank you.
Thank you so much.
That's really dumb.
Just out of curiosity.